Good morning, everybody, and welcome to our virtual dino opening here at the museum. We have a really awesome interaction for you this morning with Nicholas Carter, who's going to be taking you through some information about dinos in a minute. My name is Riley, and I'm just here to give you guys the intro and get you started so you're good to go with our AHA slides. First, I'd like to begin by talking a little bit about the museum and the land that we're on, since that's where we're filming / standing today. The museum is in downtown Kitchener in Ontario, and this land has problems this morning. Okay, there we go. Sorry, we're having a lot of technical issues. I apologize. We're working on it. So as I was saying, as settlers, we're grateful for the chance to be here, and we thank all the past people who have taken care of this land for thousands of years. Long before today, there have always been Indigenous peoples who have been the stewards of this place. For the museum's region, those people are the Neutral, Anishinaabe, and Haudenosaunee peoples. The museum is on the land called the Haldimand Tract and was promised to the Six Nations. That promise includes lands 6 miles on either side of the Grand River, which is a huge waterway that runs through our region all the way down to Lake Erie. Now, I've talked a little bit about where I am at the museum, but I don't know where you might be. And what I may explain may not be true for you. So I encourage you to check out online resources like native/land.ca to learn more about where you live and your region. All right, so we're going to pass on to our special guest here today, Nicholas Carter. So I'm not sure if you can see him, Nick, if you want to give everybody a little wave.
Hello, everybody.
Nicholas is going to be taking you through our dino activity today. We have AHA slides that you'll have to use. Sorry, we're having a lot of, as I said, this is a lot of technical issues, and I deeply apologize for that this morning. So Nicholas Carter is the coordinator of education and programming at the Philip J. Currie Dinosaur Museum. And he's worked at the museum for 4 years and has had a lifelong obsession with dinosaurs, as I'm sure all of us have, and other branches of natural history. He's also an avid naturalist who loves to learn and share new things about life on Earth. So we'll hand it over. Claire, you've got the slides. Pardon me? Perfect. Okay, so I'm going to pass it on over to Nicholas and to take it from there. So you can join your AHA slides. There's a link up top. So join AHA slides. And then you can ask questions as we go through the slides. So if you have a question, you will be prompted you can submit. If you're having troubles, you can put it in the chat and I can put it into the questions for you if you'd like. All questions will be answered at the end. So if your question's not getting answered right away, that's okay. We're on it, and we will have time at the end for questions. All right, take it away.
All right. Well, thank you very much for having me, everybody. So like said earlier, my name is Nicholas Carter, and I work at the Philip J. Currie Dinosaur Museum, which is up just a little west of the town of Grand Prairie, which is in northwestern Alberta, about 5-hour drive northwest of Edmonton. So we are both one of Canada's newest dinosaur museums in the province of Alberta, which has more dinosaur fossils than anywhere else in the country, at least discovered so far. And we're also one of the country's most far north museums. So we're kind of on this new frontier of dinosaur science up here, and we're making all sorts of interesting discoveries. And what I'm here to talk to you about today is kind of the basics of what we know about dinosaurs, answering some common questions, because while a lot of pop culture has sort of cemented a lot of ideas about dinosaurs. Science, continuously keeps moving forwards and discovering new things, and also thinking about old ideas in a new way. So once everybody's sort of ready to go, we can keep progressing on the slideshow, and we'll get to our first bit of information. Okay, looks like we have a nice little group here hanging out as well. All right, so Dino FAQs, frequently asked questions. This is pretty much everything you sort of would want to know to really get into learning about the prehistoric world. And hopefully there's some new stuff here that will interest people. So like I said, here is where we are located. We're just west of the town of Grande Prairie in northwestern Alberta. And, you can see, most of the big cities in Alberta are sort of clustered around the central and southern part of the province. So we're way out here kind of doing some new stuff. And most dinosaurs are found, historically have been found in more southeastern parts of the province. And so we're kind of catching up to the discoveries that are waiting for us up here. So we can learn more about that in a bit. So here's what we do at the museum. Our goal is to look for and preserve and display the unique fossil record of northwestern Alberta. We find a lot of stuff up here that is the same or somewhat similar to the sort of previously established fossil record from the Southern Badlands, but some stuff is a little bit different. So we were built in 2015 initially to sort of be a place where local fossils could be kept in the area so that people here could come and learn about and discover the fossil record of their own area. And we've found a lot of stuff so far, lots of dinosaur bones, teeth, footprints, other kinds of fossils from many different types of animals, ranging all the way from large marine reptiles to animals that lived in the ocean, marine invertebrates, fossilized wood. Here in this slide, you can see a dinosaur tooth and a footprint, and we even find really amazing dinosaur specimens with fossilized skin impressions. So we can learn a lot about the dinosaurs in the area by studying these fossils. So here's kind of why we do what we do. Obviously, a lot of people are aware that Alberta is very rich in dinosaur bones. And the reason for that is, there's a few reasons. One is because the Southern Badlands, like you can see in that photograph there, about 75 million years ago, were a great place for dinosaurs to live. It was sort of a low-lying, flat, swampy lowland, as you can see, and a great place for dinosaurs to live. And it was also a great place for them to die, because a lot of them stood a pretty good chance of dying and being buried in and around rivers, lots of moving water there. And so they would get buried by the sediments, little grains of sand washing out to sea, and that would cause them to be fossilized. And those sediments that were laid down in that time are now exposed in these big, amazing Badlands valleys in places you might have heard of before, like Drumheller or Dinosaur Provincial Park. So people have been looking for dinosaurs for over 100 years in these areas and have found quite a few. And we can see what conditions are like here. So as you can see, it's a little bit different. We also have dinosaur-aged rocks in this part of the province. And this preserves an inland record of dinosaur paleobiology in the province. And a lot of our fossil sites, as you can see in the bottom right corner there, that's one of our, it looks like a big sort of pile of rubble sort of cut out of the hill, which is surrounded by trees. So this is what Cretaceous rock exposures look like up here. But this is actually one of our most interesting fossil sites, despite how it looks. And a lot of sites like this overlap in time with a period in the province's history when the Western Interior Seaway, this big mass of water that had flooded Central North America, was at its highest. And so much of the southeastern part of what we now call Alberta was underwater. But this was an inland area up to the northwest where dinosaurs could continue to live and evolve. And we are actually filling in a lot of the blanks in our knowledge of dinosaur evolution and diversity by studying these Cretaceous rock exposures, which are often in these steep, remote valleys covered in dense forests and things like that. So it makes prospecting for fossils quite a bit trickier up here. But there is an underexplored richness in dinosaur fossils up here that we want to know more about. The picture in the upper right there, that's our one little patch of badlands from just east of the town of Grand Prairie that we call the Cluskin Hills, which is a very interesting place. From there, we find really little small fossils that we call microfossils, which are mostly isolated dinosaur teeth and fragments of bones. The middle photo there is a picture of what we call a bone bed, which is basically like a dinosaur graveyard, and that's one of our most famous bone beds. Comes from a place called Pipestone Creek, and it's absolutely stuffed full of the fossils of a horned dinosaur called Pachyrhinosaurus, which is kind of become now the mascot of paleontology in northwestern Alberta. And then the one down below is a somewhat what we call articulated dinosaur that's still being prepared and exposed from this big block. It's probably a big duck-billed dinosaur. So we find different types of fossils in sort of different arrangements here, and it's helping us fill in the gaps in our knowledge of dinosaurs in Western Canada. So now we're going to talk about some commonly wondered facts about dinosaurs. And this kind of applies to the whole realm of dinosaur paleontology. And a lot of people ask me what the first dinosaur ever was. And sometimes they mean slightly different things by that. Some people wonder what the first dinosaur to ever live was, or the first one that was ever found, or even the first one that was ever found in Alberta. So we're going to talk about all three. So we'll tackle the first one, the first dinosaur that ever lived. Now, this is kind of a mysterious thing to a lot of people. We don't actually know what the first dinosaur to ever live was, or the first animal that we would call a dinosaur and not, something else. But it probably looked something a lot like this. This is called Eoraptor, which comes from the Triassic period of Argentina. So this is where most of the oldest dinosaurs ever known come from. And most of them were these small, two-legged, probably meat-eating little animals. So the first dinosaurs weren't, quite all that impressive as far as size and anatomy goes. They all kind of evolved out of this ancestral body plan and diversified throughout the Mesozoic era into all the relatively more famous forms that we know of today. So that's something like the first dinosaur ever. Now, the first one ever discovered, though, wasn't the first one to ever live. And it was called this, Megalosaurus. So this was discovered in the 19th century in England, which is kind of where the scientific side of dinosaur discoveries arose. Now, people have been finding dinosaur fossils for probably thousands of years in all different places of the world, but they didn't really study them in what we now would call sort of a Western scientific mindset. And so this is the first one that sort of received that diagnosis. And the first part ever known of it was just this jawbone. And the picture on the upper right there is sort of an early Victorian idea as to what Megalosaurus may have looked like before we really understood much about dinosaurs. And we've now discovered that they were less like giant sort of land mammal-ish, crocodile-ish things and a lot more bird-like. And below is my somewhat accurate idea as to what Megalosaurus may have looked like. So dinosaur depictions have come a long way. Now, the first one ever, let's see, what do we think was the biggest dinosaur ever found? Got a poll here. So we've got a few different species here. Some may be familiar to some folks, some might not. We've got one vote for Argentinosaurus, one for Diplodocus. These are both long-necked dinosaurs. Let's see what other folks think. Many of you may have heard of Brachiosaurus. Oh, another vote for Argentinosaurus. Supersaurus sounds like it would be the biggest dinosaur, but it might not. No votes for T-Rex yet. Argentinosaurus is becoming more popular. A couple for Diplodocus. Oh, one for T-Rex, interesting. None for Supersaurus. That's interesting too. Another bump for Brachiosaurus. I have to wonder how many folks are Googling the answer right now. Okay, one vote for Supersaurus. Brachiosaurus catching up to Argentinosaurus. Okay, so doesn't look like everybody's voted yet, but I don't know if we want to show the answer anyway. All right, so looks like Argentinosaurus got the most votes. Oh, another bump for Supersaurus. And we will talk about what the biggest dinosaur ever found was actually in a bit. But I think the majority of people here are probably onto something. So we can, okay, now on to Albertosaurus. And this was actually the first dinosaur ever discovered in Alberta. So kind of fitting that it has the name Albertosaurus. Now, this was found in the 1800s by a person named Joseph Tyrrell. Some people pronounce it Tyrrell or Tyrrell. There's no real consensus on it, I think. But yeah, there's a famous museum down in southern Alberta named after Tyrrell. And yeah, he discovered the first dinosaur in the province, which was named in 1905, which was actually the year Alberta became a province, and was actually named in the same scientific paper as Tyrannosaurus rex as well. So kind of interesting little historical fact for you there. And, you know, Albertosaurus, definitely one of my favorites. Okay, so another dinosaur stat question for us. How long do we think the biggest dinosaur was? Somewhere between a school bus and 4 school buses. All right. The upper end of the spectrum seems to be the most popular so far. 40 meters, that's pretty long. Some people think closer to maybe 3, 3.5. All right, upper end of the spectrum, still Still taking the lead. And we're averaging out at around 3.6 school buses. I don't know how long 0.6 of a school bus is. But I think, again, everybody's probably onto something. Interesting thing with the length of some of the biggest dinosaurs is it's kind of ironic. A lot of the times with some of the biggest dinosaurs we have, even though their bones are so big and sturdy, we very rarely ever find complete specimens for some reason or other, and I'm not quite sure why that is. But we're often just working with a few bits of backbones or leg bones, something like that, and we have to kind of use sort of inferring based off more complete, smaller examples, how big some of these really gigantic, what we call titanosaur dinosaurs were. And yeah, it's there's still some wide estimates as to how big some of these larger dinosaurs were. So a lot of people are leaning more towards between 3 and 4 school buses in length. And I'd say that's that might even be on the small side, but why don't we advance and talk about more about that in a bit. So the biggest dinosaur, as a lot of you properly guessed, was Argentinosaurus. So this obviously comes from Argentina. And it could be up to 90 tons, we estimate, in length and over 130 feet long. So that was a very, very large animal, probably pushing the upper limits for how big a land animal could be. And like I talked about earlier, we're not going off of a full skeleton here. We have a complete or mostly complete hind leg, part of a pelvis, and some vertebrae. But this is one of the most complete giant dinosaurs we know of. Now, there could be others that exceeded Argentinosaurus in size, but we just don't have too much material from those yet. So for now, Argentinosaurus is the biggest dinosaur that we know of. So here's some other close contenders. So it's not like Argentinosaurus was sort of the biggest by far. There's plenty of other dinosaurs. You can see in the orange there, old friend Supersaurus. Brachiosaurus doesn't actually break sort of the top 5. And there's a whole bunch of these other, possibly more obscure ones as well. Oh, looks like we accidentally restarted. Anyway, so yeah, that's some of the biggest ones. So now the smallest dinosaur. See what people think. Is it the size of a dog, a turkey, a crow, or a raven? A lot of people don't actually, well, maybe not a lot of people, but some people don't know that dinosaurs could get that small. We often think of dinosaurs as being really, really big. And it was kind of surprising, back in the day when the first really small dinosaurs started to be discovered. And that's often because, dinosaurs about the size of, between a hippo or a rhino and an elephant in size, their bones tend to preserve pretty well. And that's because their bones are quite sturdy and stand a good chance of being buried and fossilized. Small dinosaurs were probably at least as common, if not more common, than the big ones. But because their bones are so fragile and, could get swallowed up by something or crushed or, broken in some way or kind of washed away by a river, in many types of ecosystems, especially in North America, they didn't stand a terribly great chance of fossilizing. But in some places like China, for example, where we have these really great areas where small dinosaurs were preserved in very sort of tranquil, low oxygen conditioned swamps, where they would basically just fall in and die and not be disturbed for millions of years. We have this amazing fossil record of these very small dinosaurs, and some of them average from about the size of a dog or a turkey to a crow sized. So, for example, something like a Velociraptor was only about the size of a really big turkey. But the smallest non-avian or non-bird dinosaurs that we know of were actually about the size of a robin. So looks like most people voted for that. And that's around the correct answer. Now, have we discovered the smallest non-avian dinosaur ever? We don't actually know yet. Maybe we'll find something even smaller than that one day. But the smallest dinosaur known to science, if you count birds in that, is actually the bumblebee hummingbird from Central America, which is about the size of a bumblebee. So that's exceedingly tiny. And the smallest dinosaur that we know of, like we said, about the size of a robin. And there's actually a few that are around the same size. We call these the Scansoriopterigids, which is a very challenging word to say at the best of times, especially when you're up early in the morning and have only had one cup of coffee. And for example, one of them is called Epidexterix. Or sorry, I actually spelled that wrong. Epidexiterix, which you'll have to forgive me. That's a tough word to say and pronounce as well. But essentially, it essentially means like long wing fingers or something like that. These were very small dinosaurs that lived in trees, and they're quite bizarre. They come from China. We don't know terribly much about them. But they had really long fingers and they were covered with feathers, and some examples even had kind of bat-like wings. So probably not what a lot of people think about when they first imagine dinosaurs, but they could take on forms as weird and amazing as this. Okay, now here's something a lot of people wonder about: the largest carnivorous dinosaur. A lot of people assume it was Tyrannosaurus rex, and for a long time, science said that T-Rex was the biggest, but we have some other ones that could be contenders as well. We've got a couple of votes from Megalosaurus and Spinosaurus. Now, Megalosaurus means essentially big reptile, so from that name you might think of it as being the biggest. Got a couple of votes for Spinosaurus, one for Giganotosaurus. Well, we might talk a bit more about Giganotosaurus, but that sounds pretty big. Now, T-Rex and Spinosaurus are tied. No votes for good old Albertosaurus yet. Okay. Oh, Giga's taking the lead. Now, a lot of people might look at that and think it's pronounced Gigantosaurus, but there's actually a sneaky little O in there. So the whole name Giganotosaurus means giant southern reptile. Saurus technically means lizard, but I tend to say reptile because it's a bit less confusing. So now we've got Giganotosaurus taking the lead. So interesting popular vote here. Oh, now somebody switched over to Spinosaurus. T-Rex down by a few votes. Well, maybe we'll move on and we may discover later what the biggest dinosaur that ate meat ever was. So, from our best guesses, it looks like it might be Spinosaurus, which is estimated to be anywhere from about 40 to 60 feet long, 10 to 20 tons. Now, that's quite a broad range. And the reason for that is we don't really know still all that much about Spinosaurus. And if you ever want to get a couple paleontologists in a very heated debate, just ask them what they think about Spinosaurus, because this is a very controversial dinosaur at the moment. And every few months to few years, some new information comes out of the deserts of northern Africa about this predator, which completely rewrites what we thought we knew about its anatomy and behavior. And it's gone from being a very mysterious land-based predator to some people thought next it was completely aquatic, and now some people are against that. And we tend not to know too much about Spinosaurus still. It's still very controversial and mysterious. That said, though, it was undoubtedly very, very big, and may have even exceeded all the other biggest dinosaurs in, at least in length, if not in weight as well. So here you can see Spinosaurus. If we're right in what we think we know about it, definitely exceeds everything else in length. Some of these South American species like Giganotosaurus, which we saw earlier, were at least as long, if not longer, than Tyrannosaurus rex. We've got a couple other ones here like Maposaurus and Carcharodontosaurus, which are close relatives. And again, we're at least as long as Tyrannosaurus. Now, T-Rex, while it may not have been the largest, it might have been the heaviest and the bulkiest, while these many of these other carnivores were sort of lightly built for their size. T-Rex was very, very bulky and was a very powerful predator. Even though it had those little arms, it had very powerful legs and an extremely powerful bite. Okay, another poll here. Which dinosaur do we think was the smartest dinosaur? You can enter your thoughts and we will see in a little bit. Velociraptor. A lot of people think maybe Velociraptor was the smartest. Well, we will talk about what the smartest dinosaur was, but Velociraptor is not a terribly bad idea. Sinosauropteryx, interesting. Oviraptor. We're definitely kind of in the right ballpark with a lot of these guesses. Oh, Spinosaurus, interesting. We're definitely sticking to the theropods. Oh, somebody said Troodon. Oh, that's good. Velociraptor again. I think one thing that we can all agree on, most of the plant-eating dinosaurs generally weren't all that intelligent, at least by our standards. And what do we got here? Troodon, raptors. I got the sense Velociraptor is very popular. Okay, then looks like it might be all the guesses. And we got a few votes for the Troodontids. And this is actually correct, at least as far as we think. So Troodontids were a rather bird-like group of carnivorous dinosaurs, relatively similar to the dromaeosaurs, or the raptors, as we would call them. It had a relatively large brain to body size ratio for a non-avian dinosaur. Now, this doesn't mean we can tell exactly what its intelligence was like, but based on the size and shape of its brain, it may have been about as smart as a modern-day duck or a chicken, which, compared to a lot of modern-day birds, isn't all that intelligent, nowhere near about as smart as a raven or a parrot, and definitely not as smart as a human or most relatively advanced mammals. But you can't really judge dinosaurs based on intelligence alone. They were definitely doing things that allowed them to survive for millions of years regardless. Okay, now what do we think was the fastest dinosaur ever? Some dinosaurs were pretty fast, some were pretty slow. Kind of tricky to tell sometimes. which ones were faster than others. Got to vote for raptors. Ooh, okay, or a couple ornithomimus. Velociraptor, no, raptor, another ornithomimus. Compsognathus, interesting. Velociraptor. Velociraptor sounds like a quick dinosaur with that name. Another Velociraptor, Oviraptor, Velociraptor again. Very popular. Definitely not a Stegosaurus. Yes, absolutely. In fact, I would guess that Stegosaurus was probably one of the slowest dinosaurs, at least the slowest of its time. Okay, well, that might be all the votes we'll get. And so those who guessed ornithomimus are definitely onto something here. Now, we don't know exactly what the fastest dinosaur in the fossil record was, without a doubt, but it was probably one of the ornithomimid dinosaurs, which includes ornithomimus, as well as this one, Struthiomimus. These are what we call the ostrich mimic dinosaurs, and they were probably about as fast as an ostrich, estimated to be between 70 to 80 kilometers per hour at most. And there's a few reasons we think this. They had very lightly built skeletons, and if you look at their hind limbs, they're built very much like an ostrich, similar proportions, very short thigh bones, very long shin bones, and very long feet bones. So that tells us that they were built for running. Now, interesting thing about Velociraptor is while it was probably relatively quick over short distances, Velociraptor wasn't actually really built for long distance sprinting. So it wouldn't really have ranked among the fastest dinosaurs, even though that's what Jurassic Park would have you believe. Now, how long were the dinosaurs around for? Some people think that dinosaurs were kind of, just around at the same time, the same place for some amount of time, and they all went extinct, and then people showed up. But let's actually have a look. So here is kind of a very sciencey looking chart showing all the different periods and eras and eons and everything that we know about the record of geology. So this spans, over 500 million years, back from the first animals ever to the, modern day up at the top of the Holocene there. Now, dinosaurs, if we click next, there will be some graphics pop up. So they show up in the not Triassic. Sorry, Triassic. The Triassic, not the Jurassic. And so that's about 225 million years ago. And if we click next again, we'll see when they ended at the top of the Cretaceous period there, which was about 66 million years ago. So they spanned that whole length of time. And then they went extinct at the very end of the Cretaceous, and there should be some more stuff pop up. And then birds, the last lineage of dinosaurs, continue on throughout the Cenozoic, which we call the age of mammals, even though it wasn't just mammals around back then. And then humans show up kind of near the very top. So dinosaurs were around for a very long time. So that's sort of the span of human history right there compared to the length of time that dinosaurs were around. Now, how many types of dinosaurs do you think people have found? We often tend to think about dinosaurs, just there being a handful of them out there. We can name, a lot of the famous ones, but we're always discovering new ones. And, even back in the day when they were finding things like, celebrities like Triceratops and Tyrannosaurus, paleontologists were naming a lot of other dinosaurs that kind of flew under the radar a little bit. So we have a guess for 1,000 or in the thousands. 18. 5,000. You have quite the range of guesses here. Another couple of thousands. 1,000,000 dinosaurs. Oh my gosh. It would be great if we could name 1,000,000 dinosaurs. $5,000, $6,000, 1,000 billion. I don't know if 1,000 billion creatures have ever lived on the planet. We don't know. Question mark. $500. Okay, why don't we talk about that? So far, some people are kind of both right. Now we have about 500 at least genera of dinosaurs. So, all dinosaurs have kind of a first name and a second name. With most species, we only call them by the first name. For example, Triceratops, that's an example of a first name or a genus of dinosaur. So is Tyrannosaurus. And then the species name comes after that. So in Tyrannosaurus, the species name is Rex. So that's its full name. And there's just that one species of Tyrannosaurus, Tyrannosaurus rex. If we were going with Triceratops, there's actually two species of Triceratops, Triceratops horridus and Triceratops prorsus. So we've got about 500 first names of dinosaurs and about 1,000 species. Now, this is always growing because just about every week, somebody is discovering and describing a new genus of dinosaurs. So who knows how many we may have in 100 years' time. It's always kind of going up and up. Maybe one day we'll get to 1,000,000. So here's just a small sampling of all the different types of dinosaurs that we have found so far, and we're always adding new ones to it. And then today there is over 10,000 living species of birds. And this is sort of my opportunity to show off my own bird geekiness, some of the pictures I've taken in and around my place here. And these are still, dinosaurs themselves. So dinosaurs are doing very well to this very day. We've got lots of them around still with us. What words would you use to describe what a dinosaur looked like? So think about what a dinosaur may have appeared like in real life. Would you describe it as big or small, scaly, fuzzy, furry maybe? Did some dinosaurs have hair? Some people think maybe. Scary, giant, and feathery. Interesting. Some dinosaurs were definitely scary, giant, and feathery. Oh, crocodile, mouse. There is actually a species of dinosaur called Mosasaurus, which means mouse reptile. So it's a very small dinosaur. Powerful, amazing. I agree with that. Feathers, definitely. Great cheekbones. Some dinosaurs did have very sturdy cheekbones. Scaled, birds, sharp claws, definitely some had sharp claws, spiky tail, some had spiky tails, some had horns. Very nice. Well, I like some of these words, and just about all of them are pretty accurate. So if we want to move on, we can see what we know about what dinosaurs look like. So some of them definitely had scales, and we can tell that by soft tissue remains. You can see at the upper right there, or the upper left, sorry, is an example of an Albertosaurus, a big duck-billed dinosaur that was found near my museum. And well, it's not my museum, but the one I work at. And you can see it's kind of a lumpy texture on the rock there, and that is actually the preserved or sort of a natural rock cast of the dinosaur's skin. So that one was scaly, thanks to wonderful what we call articulated specimens, these skeletons that are in sort of all the position that they would have been in the dinosaur's life, like that Gorgosaurus, that Tyrannosaur down there. And then we can look at modern day relatives, like the skeletons of modern birds, like the one on the right there is a magpie that I actually put together. And a lot of the bones are quite similar to what we see in dinosaurs. So we can look at animals like that and figure out a thing or two about prehistoric dinosaurs. And then we have some amazing examples like this really famous armored dinosaur, Borrelia pelta, kept at the Royal Tyrrell Museum. And this might be the most well-preserved dinosaur ever found. It's definitely the most well-preserved one found in Alberta ever. And it essentially is if you took the dinosaur and just turned it into rock without removing any of the soft bits or the bones or anything, this is what it would look like. So it's definitely once in a lifetime find. Okay, poll time. Do you think birds evolved from dinosaurs? We've talked a little bit about birds and dinosaurs, their relation here. But do you think it's true? Looks like we have a few people in favor of yes. Oh, one person is against it. Most people are pro birds as dinosaurs, though, it seems. Now, this was an idea that actually, oh, we've got another for no. This was an idea that was quite hotly debated for a long time, and it actually goes back further than a lot of people might think. The first people to ever suggest that birds had some relation to dinosaurs was actually back in the mid to late 19th century, when they started looking at the bones of birds and dinosaurs and figuring that maybe there was some connection here. But if we have all the answers, we can talk about it. So the answer to this, we can actually figure out by some really, really amazing stuff. Now, we talked earlier about smaller dinosaurs, many of them coming from China, being preserved in these oxygen-poor wetlands, these bogs, things like that. And here we can see a whole bunch of the close-ups of these dinosaurs here from Asia. And the sort of filament-like fluff that you're seeing around the bones, these sort of outlines around the skeletons, these are actually preserved feathers. So, the only animals alive today that have feathers are birds. So this is one big clue that modern-day birds are indeed just a type of dinosaur. And these skeletons all actually, the outline of the dinosaur might not be all that bird-like in some cases. The individual bones are often hollow and very similar in shape to the bones of modern-day birds. And this is the one that kind of started it all. This is Archaeopteryx from Germany. And you can see it has individual fingers with claws like a dinosaur and a long bony tail like a dinosaur. And it had teeth like a dinosaur as well. All birds today have toothless beaks. But you can see the wing feathers and the tail feathers there. So what happens during about halfway through the time of the dinosaurs, sometime during the Jurassic period, is some of the small sort of carnivorous, snippy little meat-eating dinosaurs developed feathers. We don't know exactly when feathers showed up, but it was at least by the end of the Jurassic period. And some of them kind of maybe took to the trees and maybe had feathers to maybe help them keep warm. Some people think maybe they used feathers to show off to each other or to glide from tree to tree. Maybe all of those are correct. And many different lineages, different families of feathered dinosaurs showed up, but they all went extinct except for one, and those today we call birds. So feathers have all sorts of purposes for dinosaurs that may have contributed to their origin and evolution. Definitely for keeping warm. Feathers are better for that than fur actually is. Feathers are good for keeping you waterproof and for showing off. You can see at the bottom there is a green-winged teal, which is just a type of duck, and the male has that lovely green stripe on his head to show off to the females. Feathers are obviously often good for getting around, for flying, and for streamlining your body. And that woodpecker there, its feathers aren't useful for only keeping warm and flying, but it has these tough little feathers around the base of its bill that keep the sawdust out of its nose for when it's pecking on trees. And we can see the origin and evolution of bird-like traits in the skeleton as well. So at the upper left there is a Dromaeosaurus, which is a kind of raptor related to Velociraptor. And on the right there is a skeleton of a turkey vulture. And while they might not look terribly similar, Anchiornis down there on the bottom left, we can think about as kind of not really a true intermediate between the two, but something kind of like that. You can sort of see some of the trends in the evolution of bird skeletons. The tail gets shorter. The finger bones are separate early in dinosaurs, and they kind of fuse up together to form the wing of a bird, and the arms get longer. Legs start to get a bit shorter in some cases, and the heads go from toothed jawed skulls to toothless beaks. And there's all sorts of other trends in the evolution of bird skeletons. You all have collarbones, at least many of us do. And in birds, those collarbones would fuse up over time to form the wishbone, which you can see that U-shaped bone there. That's what that is. And we can see the evolution of the bird's ability to fold its wing with the wrist joints there that showed up in dinosaurs. And then that highlighted bone at the top there is called the pubis. And you can see how in the evolution of birds that starts to turn backwards. Okay, another question for everybody. Are dinosaurs a type of lizard? We've often heard that the word dinosaur means terrible lizard, but are they true lizards? Related to modern day things like geckos and skinks and monitors and such. Well, a few more people are saying no. Oh, a couple people say yes. More people say no. Still more popular with the no's, but some people think yes. Oh, we might have a tie here soon. This is interesting. I wonder if somebody will break the tie. Well, it looks like we're not too sure, so if that's all the votes, we can move on. So, are dinosaurs actually lizards? So, like we said, the word dinosaur comes from ancient Greek, meaning dinos, terrible, potent, or fearfully great, and sauros, which technically means lizard, but in some sense is used in paleontology to just mean reptile. It's always a good idea never to take the names of dinosaurs terribly seriously. And this was coined in 1842 by this old British paleontologist named Richard Owen. So let's take a look at the next slide and we will see. So this graph or this diagram I made up kind of shows the relationships of animals with backbones aside from fish. So dinosaurs, you can see at the upper right there, they are actually not lizards. They're closest relatives today, not counting birds because birds are dinosaurs. Their closest living relatives are crocodiles. So that is a picture of a gharial, which is a kind of crocodilian that I photographed in San Diego a few years ago. And crocodiles and dinosaurs have a lot in common with each other. In some cases, they have non-overlapping scales. They take care of their young, and they tend to have a slightly more upright posture. And they're more closely related to each other than either is to lizards, which includes snakes. So crocodiles and dinosaurs are in this group together that we call the archosaurs, which means the ruling reptiles. Lizards and snakes are in their own group called the lepidosaurs. And they have mobile hinges in their skull joints, overlapping scales, kind of like a suit of armor over their body. Turtles, we don't actually know for sure where they fit in with this, but some think they might be closely related to dinosaurs and crocodiles, or slightly close. Some think they're more towards lizards and snakes. Not too sure, and I'm not going to get into that today. And then all of those animals that we call the reptiles are more closely related to each other than they are to mammals like us, represented by the moose there, which just have one hole in the back of their skull instead of two, like reptiles do. And we have hair, feed our babies with milk, and have all sorts of other traits that make us unique. And we're still more closely related to reptiles than we are to amphibians, like that little wood frog there, because we don't lay our eggs in water in this big, massive jelly and things like that amphibians do. So just because something is prehistoric, by the way, doesn't mean that it's a dinosaur. All of these fossil animals that you see here are actually not dinosaurs. So many different types of species came and went throughout the fossil record, some more closely related to each other than others were. So how do we think that the non-bird dinosaurs went extinct? Let me know what you think. There's some ideas floating around out there, and some people might have their own ideas. Okay, first guess is the meteor hypothesis. Asteroid, okay. Climate changes. Volcanoes. Could not fly to escape. Food sources. Maybe they ran out of food. Okay, maybe we'll move on and see what the actual answer is. So a lot of people were kind of all right at the same time. So what happened was, it was indeed a meteor that hit the Earth that killed the dinosaurs, but that led to things like volcanic eruptions, lack of food, climate change, things like that. And here's our evidence for that. So during the end of the Cretaceous, between the end of that and the start of the Paleogene, which came next, we can see in the fossil record this massive deforestation. All sorts of different animals go extinct. We also have this layer that we call iridium between these two ages in the geologic record. Now, iridium elsewhere on Earth is quite rare. It's not a very common mineral, but it is quite common out in outer space in things like asteroids. We also have this great big crater in Mexico that is on the Yucatan Peninsula near the town of Chicxulub. And you can see in that diagram to the left there, half the crater is on land and the other half is actually in the ocean. And this dates to the very end of the Cretaceous period. So the proper term for this asteroid theory is called the Alvarez hypothesis, which was first published in the 1980s. And it kind of explains everything about how the dinosaurs went extinct. So essentially what we think happened was this meteor hit the Earth in what's now modern day Mexico, and it was a very, very powerful explosion, about as powerful as 1 billion atomic bombs going off, which would be very, very terrible. All sorts of rock and dust is thrown up into the atmosphere, and then what happened is molten rock, sort of superheated rock, starts raining down. So it's literally raining fire. And then the atmosphere, the air around the Earth gets superheated, which caused all of the forests to catch fire at the same time throughout the world. And then the force of the impact caused tsunamis to sort of blow inland and bring, essentially bringing the ocean, hundreds of kilometers inland. And all the dust and ash and things like that from the fires and volcanic eruptions triggered by the impact essentially block out the sun. So anything that survived those first very, very terrible days couldn't get enough to eat because the sunlight was blocked out, which means that animals that use photosynthesis, like plants and algae, died out. And so all the food chains around the Earth essentially collapsed. And, big plant-eating animals like big herbivorous dinosaurs couldn't get enough to eat. So they go extinct, their predators go extinct. And that's essentially a summary of what we think happened. The bigger question is how the heck did everything else that's still around survive? There was things like snakes and lizards, birds, crocodiles, all sorts of other things, early mammals were around back then. How did they manage to survive this terrible ordeal? I think that is the bigger question. Okay, so now we have some of our own questions. So glad to see there are quite a few here. First person asks, is there only a few scientists that think that T-Rex had feathers? The whole T-Rex having feathers thing is very kind of a hot topic in paleontology right now. We've kind of swung back and forth right now. The last publication in Science on T-Rex feathers was actually kind of against T-Rex having feathers. We know some earlier relatives of the Tyrannosaur family from China definitely did have feathers, but what it's kind of looking like is by the time we get to Tyrannosaurs near the end of the Cretaceous period, like T-Rex, as well as its close relatives like Albertosaurus, Gorgosaurus, Tarbosaurus from Asia, we have impressions of their skin, but it just shows scales. We don't have evidence of feathers. Now, maybe they had reduced their feathers, and maybe they had some on their body, or maybe their feathers had basically become really small and looked like hair and didn't really fossilize. That could be the case. You can kind of think about elephants. Elephants come from hairy ancestors, but modern day elephants are really big and live in warm climates where they don't really need hair. Sorry, not feathers, hair. So they've really reduced the amount of hair that they have. So maybe T-Rex was kind of like that. That's kind of what I think, at least. Next question is, were all dinosaurs feathered? No, there was definitely many dinosaurs that had scales, maybe some that had parts that had just bare skin on them. Which dinosaurs exactly had feathers and which ones didn't, we're still trying to figure out. And we're also trying to figure out when exactly feathers first appeared in the evolution of dinosaurs. So kind of the safe bet is at least many of the meat-eating dinosaurs, the ones more closely related to birds, like the raptors, tyrannosaurs, aside from the really big tyrannosaurs, the ornithomimosaurs, things like that, had feathers. Looks like many of the big plant eaters didn't. We have some plant eaters that are covered with fuzz, which might be feathers, really, really small early plant-eating dinosaurs. But the larger, more advanced ones like horned dinosaurs, stegosaurs, ankylosaurs, stuff like that, we're not finding any feathers. So it's really tricky to say. Why were dinosaurs so small back then? Well, basically, when most different animal groups first evolve, they tend to be relatively small, and it's only after a lineage of animals has been around for a long time that they tend to get really, really big. So there are some advantages to being really big, but there's also advantages to being really small as well. And kind of like modern day animals, some dinosaurs were really big, some were really small. So if you're smaller, you need less food, and you also need less space to live in. So in a lot of ways, it's easier to be small. And then if your sort of family or your descendants are in one particular area for a long time and can get enough space and food to eat, you can start to get really big, and that helps you to keep safe from predators. But if you don't have to worry about a lot of predators and you only have so much space and so much food to go around, it's better to stay small. Was Triceratops the largest ceratopsian? So ceratopsians being the horned dinosaurs, and it seems like it was. It was at least one of the biggest. We have Titanoceratops from the United States, as well as Eotriceratops from central Alberta, which were at least as big as Triceratops. But these are the biggest horned dinosaurs, all about the size of a really big elephant, about 6 tons or so. So Triceratops was one of the biggest, at least. What is your favorite dinosaur? Mine is actually Triceratops. Don't know why, always has been. Were all theropods carnivores? No, they weren't. So theropods, again, are the two-legged, often meat-eating dinosaurs, which often had sharp teeth and feathers and stuff. Many of them actually evolved to become herbivores. Things like the oviraptor dinosaurs, the ornithomimids. There's many other examples out there. Sort of independently lost their teeth and evolved beaks, and lived like, kind of like ostriches do, pecking at seeds and, flowers, fruit, things like that. So kind of interesting evolution there going on. Were all dinosaurs feathered or scaled? Some had one, some had the other. Some dinosaurs probably had feathers and scales at the same time. There's surely no sort of hard and fast rules with dinosaurs. It's all very kind of confusing and a little wishy-washy sometimes. How many types of dinosaurs are there in the world? Well, I think what did we say? There was about 500 different types of dinosaurs, at least as far as their first names go. So that's about how many we've found so far. But how many are out there waiting for us to be found? We have no idea. Could be 500 more. Could be more than that. What is the funniest dinosaur name or meaning? That's an interesting question, and there are probably a few kind of funny names out there. One that springs to my mind first is Pachyrhinosaurus, and that name means thick-nosed reptile. Some of the funniest names out there, I think, might not actually be dinosaurs. There's a kind of animal called an entelodont, which kind of look like giant pigs, essentially. And there's one type of entelodont called Dinohyus, which literally means terrible pig. So that one kind of makes me laugh. Why did the meteor come to Earth? So there actually isn't really like a why to that. It's not like the meteor was sent by anybody or that it meant to come to Earth. It was just flying through space on its own, and it was bad luck, bad timing that on its trajectory, the Earth was in the way, and then it just hit the Earth. So total accident. Do we know for sure how dinosaurs went extinct? The only way we could really know for sure without a doubt is, basically to go back in time and witness it happening. But I'd say we're about 99% sure that the meteor impact is the way that it happened. Some of the details we're still kind of working on, but yeah. Why did the continents break up? So we haven't really touched much on this, but it is true that the continents have moved around on the Earth's surface. And during the time of the dinosaurs, they were all together and then kind of split up. And, dinosaurs were sort of isolated on different continents. Now, the reason for that is the continents are just the very top of these plates. So the Earth is kind of, a ball of, semi-liquid rock, magma. And the continental plates are just this crust. You may have heard of the Earth's crust that just kind of sits on top of this ball of really hot goo. And they kind of just drift around by the forces of physics. And sometimes they'll collide into each other and one will kind of go over top of the other. And they just kind of shift around that way. And because of that, the shape of the continents not only move, but they kind of change shape as well. That's about as well as I can put it. I'm definitely more of an expert. Well, not really an expert, but know more about dinosaurs than I do about the way continents work. But that's, essentially it. Were there really big dinos and really small dinos at the same time? Yes, there definitely was. So it's not like we had periods where there was only small dinosaurs or only big dinosaurs. Think about modern day mammals today. If you went to Africa, you could find animals as big as elephants. And then you could also find animals, like mice and shrews. So they definitely existed at the same time in the same places. There was dinosaurs about the size of robins living alongside ones that were the size of rhinos. Next one, are pterodactyls dinosaurs? No, so they are in a group that we call the pterosaurs, and pterosaurs are probably very closely related to dinosaurs. They're in that group we talked about earlier called the archosaurs, which, crocodiles are a member of as well. But they branched off before the evolution of the dinosaurs, but they lived at the same time in many of the same places, and pterosaurs went extinct at the same time as the dinosaurs. But they have sort of their own special anatomy that separates them as their own group. So, they're kind of their own thing. Are sharks descendants of some dinos? No, so sharks are actually much, much older than the dinosaurs. And they're in, essentially what we would call fish. What the word fish means in science is kind of vague now, but sharks are not closely related to dinosaurs. They have gills and fins. They can't breathe air, and their skeleton works very, very differently from dinosaurs. So also, just because they were around at the same time doesn't mean that they are dinosaurs themselves. How long was the neck of Albertonectes? That I actually don't know off the top of my head, but I'm sure if you looked it up on Google, you could find out. Albertonectes is a plesiosaur, by the way, one of those long-necked sort of Loch Ness monster-looking animals, but it actually existed. That lived in Alberta during the time when it was underwater, and it had the longest neck of any plesiosaur ever known. So I forget how long the neck was, but I'm sure it was very, very long. Thank you for the presentation. Well, thank you for coming to it. And I do believe that is the end. So again, thank you everybody for coming and learning a thing or two about dinosaurs with me.
All right. Thanks, Nick, for taking time out of your day to take us through this. So I wanted to thank everybody for participating. And again, thank you, Nick. And don't forget, if you enjoyed this, to follow. I'll put some information in the YouTube chat of where to follow more things that Nick's up to. And don't forget to join us again at 1 o'clock, where we're going to be doing a little dino puppet. Nick, feel free to join us if you want to make a little dinosaur puppet.
Thank you.
And yeah, thank you, everybody, and have a great lunch, and we'll see you in a bit.